Welcome, and we're going to look at some more examples of function combination. This first example is one of my favorites because the type of problem is called sparse data, and the reason it's called sparse data is because we're given some data about the function, but not all the information. So hence sparse data. Okay, so we know some information about p and q when those functions are evaluated at -2, okay? And we want to find, what we get when we add them, multiply them, and divide them. Okay, so let's just kind of do this. And so we want to find p plus q of -2. And so by definition, right, this is p of -2 plus q of -2, okay? Not a big deal. According to the problem, it says p of -2 is -4. Oh, okay, so just replace that with -4. Q of -2, it says is 3. Okay, add -1. Boom, done. Okay, PQ of -2, right? By definition, this is P of -2 times, right? No symbol there means implied multiplication. Q -2. Okay, P of -2 is -4, and Q of -2 is +3. Multiplying together, you get -12. Boom, done. Okay, last one, Q over P of -2. Okay, so this would be Q of -2 over P of -2. Okay, according to the definition, Q of -2 is 3. P of -2 is -4, and I can't go any further with reducing. Okay, so again, you may be given some information about functions. Use the information appropriately according to the definition. That's the big takeaway here. And in addition to sparse data, we can also give you functions that are defined in graphical form. Okay, so this one says f of x is in red. Okay, so I have to label this as f of x, and then g of x is in blue, right? Okay, there we go. And it says use them to sketch the graph of h of x, which is the sum on an appropriate domain. Okay, I want to handle the domain bit first, just for my own sake. Okay, so if I look at the domain of f, right? Domain of f, it says here this is -1, and then that has a parentheses, right? It has an open dot, and then that would continue until 3 with a bracket. Domain of G, okay, this is -2, there's an open there, and then continues until 2, bracket. Okay, and then just so I can see this more visually, so I have -2, -1, 2, and 3, okay? And so I'm just going to do these. F of x was from -1 to 3, and g of x was from -2 to 2, right? And the domain, right, if I'm adding them, it's going to be everything that they have in common. Okay, so that's everything in here up until +2, and I have to stop. So the domain for f plus g, which is the domain of h, would be -1 exclusive, right? Because they don't have -1 in common, but just to the right of -1 they have that, and then all the way up until 2 and including 2. Okay, so that's the domain that I'm going to be using. Okay, one problem solved. Now I need to sketch the graph. Oh my goodness, what do I do? Well, do the operation, right? Sometimes I find that this information in the graph can be a lot to digest. Like maybe you could do this mental arithmetic, maybe you can't. So what I might do is say, okay, well, here's my domain. Okay, I'm going to make an XY chart. Okay, so I know my domain needs to go from -1. I'm actually going to put a hole here, but I'm still going to put it in my table of values. 0, -1, 0, 1, 2, and then I'm just going to list F, G, and then, oh, that's a long G, and then H, okay, and I'm going to put kind of a line in between just so I can kind of separate them spatially. So what is f at each of these values? Well, let's see. I don't have the value, but again, it's a whole. The y value would be 3, and then at 0 it is 4, and then back down to 3, and then at 2, it's at 2, okay? G, right, again, at -1, G at -1 is -3, and then -2, -1, and 0, okay? So then to find H, right, H of x is just what I get when I add them. So literally add them, okay? F plus G, so that'd be a 0. 4 minus 2 is 2, and then 3 minus 1 is 2, and then 2 plus 0 is 2. Oh, okay, that's exciting. Not really. But that's okay. So I'm going to plot h of x in green, okay? So now I'm going to plot, say, at -1, right? At -1, the y value is 0. So I'm going to put a hole there, again, because the domain has a parentheses, okay? And then at 0, I'd have 2. So plot that, 0, 2, 1, 2, 1, 2, and 2, 2, okay? So what does it look like? Well, I have some idea, right? I have some points, and honestly, some points are enough right now. This is a sketch. If we wanted to find them exactly, we would use a computer algebra system or a graphing software. So I might just say, let's connect the dots and call that good. And this will be our function h of x. Okay, so to review what I did first, I had to label the graphs for my own sanity, and then I found the domains of each, intersected them to find the domain of h, right? Just so I knew, like, okay, these are the x values I'm working with. So I actually did the second part first, found the appropriate domain, and then I went back and said, okay, let's find the function values by performing the operations. So I made a table of values just to organize my thoughts. Otherwise, if you wanted to, you could have said, okay, this is, you know, +3, this is -3, okay, I get 0. If this is at 4, this is at -2, so 4 minus 2 is 2. Okay, you can just do the mental arithmetic too, but sometimes making the table really helps organize your thoughts. So another strategy to keep in mind if you're given a graph, and feel free to use these in our other work with function combination.